After selecting the studies, we are ready to extract the data needed for our meta-analysis. This is the fourth step of the 8 steps of a meta-analysis. What data do we want to extract? Of course, effect sizes. We want to say something about the size of the effect. So sometimes effect sizes are immediately reported in the papers, but sometimes we have to calculate the effect sizes, and we now extract summary data, test statistics, p-values, and so on that can be used to calculate effect sizes afterwards. But we are not only interested in the size of the effect, but we are also interested in the confidence about the size of the effect. So we also want to extract data like standard errors, the sample size, test statistics, p-values, because these also give an idea about how precise the size of the effect was estimated. Typically in a meta-analysis, we do not only estimate only a mean effect size, but we also are interested in study characteristics that are related to the effect size. So it's also a good idea to extract other information about the studies, like for instance, characteristics of participants, the way the dependent variable and treatment was operationalized, some contextual elements, the tests that were used, the design that was used, the quality of the study, and so on. So this is not only interesting for doing moderator analysis afterwards, but it's also a good idea in your systematic review that you give a clear overview of how the studies that you found look like. This means that you will collect a lot of data. How are you going to collect these data? Well, it can be a good idea, or it is a good idea to use a coding scheme. So for instance, one sheet, one paper for each, or one document for each study, or for part of the study. So if you extract data, it's always a good idea to, well, you could, for instance, copy exact sentences from the original paper. But what is important is that you also clearly mention the page numbers, so that afterwards, if you want to go back, if you do not remember very well what that meant, or if you want to know more about the context in which that sentence was given, you can easily find back that part in the text. Note that it is better to code somewhat too much than too little. I mean, if afterwards you say, well, maybe I also need information on that characteristic, and you did not code that yet, then it is much more work to extract the data, it's much more work if you have to look at all individual studies again to look for that variable. It's better to code a characteristic too much, even if you will not use it afterwards anymore, than one too little. But of course, also pay attention. So if you have a very long coding scheme, so if you want to extract a lot of information, it can also be very time consuming. So also think about what information I will use afterwards, so that you do not code far too much. So here is an example of such a coding form. So so these are some study characteristics, and so in the blanks you fill in that information for the study. So afterwards, so when you filled in these coding forms, it is probably a good idea that you use a spreadsheet program like Excel to bring together all these data, so that afterwards you can analyze them in a statistical program or in a program specifically for meta-analysis. So here for this study, we used several sheets. So in the first sheet, you see in the first sheet we have one line for each study. And so in the first column, in column A, you can see the study ID. So the first study was study 10,001. So in the second column, you have the publication year, which was 2012. In the second column, you have the publication type. I think one was published and two was unpublished. And then in the fourth column, you have another characteristic. So here you have an overview of all studies that were found. So probably another column is the authors and so on, or the complete reference. In a second sheet, we have here again the study ID, but now we also have an additional column, sample ID, and you see that for some studies, like study 10,012, you have two samples. So in that study, two groups of persons were studied. The same is true for study 10,018. So also there were two samples. So whereas the first sheet had one line for each study, in this sheet we have one line for each sample. For the majority of the studies, there was indeed only one sample, but for some studies there were more than one sample. And then in the following columns, you have some characteristics of these samples. In a third sheet, you have the results that will be used afterwards to calculate effect sizes. Or yes, this was a study about the reliability coefficients. What you see here in the last column are the alphas, so the reliability coefficients. But for some studies, and for some samples, you had different scales that were given to these samples. Like for instance, in study 10,003, so in sample 1, there was the scale LACA LPART and LACA LPEERS. So two different subscales of the LACA scale. And so for each of these subscales, you have an alpha coefficient. So in that way, by using multiple sheets, it is possible to keep the number of variables and the number of rows limited. Of course, it's important that you can link these different sheets to each other. So make sure that in the 3 sheets, then you have the same variable names, like for instance, ID study and ID sample. Also, for the data extraction, it's important that you make sure that this is done in a reliable way. So also here, you have to make sure that your coding scheme is very clear. So again, for consistency, but also for replicability, it's important that this scheme is very clear and that you report on that scheme as well, or that you make it somewhere available as supplementary material linked to your paper, for instance. Also here, the coders should be trained. Also here, it is a good idea to let at least part of the coding done by 2 independent coders and to report on the reliability.